Yeah, I'm Metью Uайтінг. I'm with Washington State University in the Department of Horticulture, and I work at the Irrigated Agriculture Research and Extension Center in Prosері. What we're doing is testing a field application for artificial, or sometimes we call it mechanical pollination. The idea is to replace pollinators, which are honeybees, and also in the future to replace the use of pollinizers, which are those trees that are interplanted to provide the pollen to set a commercial crop. And we developed a vision for a solution to these issues, which is somewhat similar to what's available commercially. The main exception is that we intend to do a full replacement of pollinizers and pollinators with an artificial system. So after doing those pilot studies last year in apples and cherries, we're taking it to the next level this year. We're working with many grower collaborators around the state and using a large size electrostatic application system. And so, for example, today we're in a Thyatine orchard, which is chronically underproductive. And so we're looking at, can these supplemental pollination strategies increase yields and do so in a sustainable way. Before we can go to the field, a couple of things have to happen. The first of which is pollen has to be harvested. We learned a lot about the kind of pollen that needs to go into this experiment. We learned that it needs to be very fine grade, essentially pure pollen, and that's an additional step in the preparation of the pollen. But we need that in order to make a nice consistent suspension and not have problems with the filtration in the application systems or also with the nozzles, having any plugging at the nozzles. The other key part to it is to develop the suspension. So we're putting it into a liquid. And if you put a dust into a liquid, it's just going to settle and scatter across the top. So we're working in our lab studies all winter at looking at the constituents of a suspension in order to break the surface tension and get a nice even distribution, a nice even suspension of this pure pollen in the liquid. Today was actually the first time that we've brought it to the field, and I think you saw some of the challenges that still remain. Now, the way that we're testing and evaluating the effectiveness of these supplemental pollen applications is to go and count flowers. So you saw some examples in the orchard where we had branches flagged, and we were in here 3 or 4 days ago counting how many flowers there were on these branches, and then we have 1 or 2 passes with the supplemental pollination system, and then we'll return just prior to harvest and we'll evaluate how many fruit were there. So we'll compare where we did provide the artificial pollination and where it was just natural pollination. What we also do is collect some flowers post-application, and we'll rinse those out with a mineral oil is what we use. And you saw a graduate student collecting flowers and rinsing off the stigmatic surface. That's where the pollen should be landing. And then we collect that liquid and we evaluate how many pollen grains were there. So we're comparing where the bees were naturally pollinating the crop versus where we went with the artificial pollination system to prove that, yes, we've put this pollen through the system and it landed on the stigma. Our goal is that we increase fruit set. So for example, every 100 flowers where we passed with the pollen, maybe we've got 50% fruit set, whereas in the untreated, maybe we have 20 to 30. This is our goal, to increase fruit set, increase yield and productivity. Now what you saw in this orchard was an assessment of 2 different artificial pollination strategies. One is supplemental pollination. So that's which is the majority of this block. You pass through with the sprayer and we're adding that pollen to the open pollination process. So we're supplementing the natural pollination process. We've got another trial in here where we came in prior to any flowers opening and put cages around the branches that would keep out the bees. So now the flowers are going to open naturally inside these cages. They will not be pollinated by bees. They will only be pollinated when we pass with the pollination system. So that's an approach that we're calling replacement pollination. This is a scenario that we can see in the future where, again, there are no pollinators and there are no pollinizers, and one would be able to fertilize their crop successfully simply by utilizing an artificial pollination system.